So I'd like to now introduce Amy and Karen from the National Museum of the Royal Navy, who are going to talk about harnessing generative AI to enhance collections data. So over to you guys.
Great. Thank you so much. And thank you for having us here today. We're really excited to talk about some of the experiments that we've been doing using AI, and particularly generative AI and large language models on our collections data to see how we can enhance it. So just to give a little bit of background to begin with, for those of you who aren't familiar with the National Museum of the Royal Navy, we have sites across the UK. So Karen and I are mainly based in our headquarters, which is in Portsmouth, where we have HMS Victory. We also have across the water our Submarine Museum and our Explosion Museum of Naval Firepower, but we also have sites up in Hartlepool, where you get HMS Trincomalee, as well as over in Belfast, where HMS Caroline is. So we have lots of ships, unsurprisingly, as well as really large collections, as Karen's going to tell you about. So a little bit about me. Again, I'm Amy Adams. I'm the Collections Information and Access Manager for the National Museum, and I primarily look after our archive, library, photographic collections, as well as looking at our collections management procedures and how we make collections accessible, which, as many others today, is more and more digitally based than it used to be. So looking at how we do things like collections online as well.
Hi, I'm Karen Clarke, and I work with Amy as the Collections Information Coordinator, mainly looking after our CMS and our digital asset management system, Piction, as well. So why were we interested in looking at AI? So the National Museum of the Royal Navy has extensive collections, estimated about 2.5 million items, including the archives and the library, with our data catalogued to Spectrum standards in axial collections. This data, as of many museums, is of varying quality, and we recognise the potential for using AI to enhance some of our historic records. Our data often contains specialist descriptions, but not necessarily easily searchable metadata like keywords that would make the collection more accessible to our users. We've also been considering our potential curatorial bias and historic colonial references, adding content warnings where appropriate. We wondered whether AI could help us understand our collections in different ways and provide new routes into them for the user. We wanted to explore whether there were free AI tools available that could support our work, or if the use of paid tools equated to greater accuracy. The opportunity came last year to work with academic partners at the University of Southampton in the Centre for Operational Research, Management Sciences and Information Systems, known as CORMSYS. We ran initial master's students projects during the summer of 2023, and this was a successful partnership which fueled further projects this summer. It has also spawned further partnerships with researchers who are associated with the Catholic University of Leuven. Within a similar period, we were also contacted by our CMS provider Axial to take part in a beta project, and Amy is now going to highlight some of this work with a few case studies.
Like Karen mentioned, we've kind of been testing and doing experiments all across our collections data because we've been a bit obsessed about AI and how it can perhaps help us in the future. And the first one that I was really interested in, and we first offered to the CORMSYS master's students last year, was keyword extraction and how we could kind of get keywords out of it. So, you know, our curators write really well written brief descriptions of the collection, but in order to make things really searchable, whether that be internally on our Axial system or externally through our online collection, you need those keywords like associated subjects or people or locations to really help have that controlled terminology and make searching as valuable as possible. But that can take our curators a really long time to generate. You know, they can write a really lovely brief description and then take another like 45 minutes to add a bunch of keywords, and even then have they necessarily tagged everything that somebody might look for. So we wanted to see whether there were AI tools that could do that, and we offered it to one of the students who did come out with not a generative AI, but they used what is called a Yak Python script to kind of look at that. And there is a kind of a lot of use and keyword searching and AI tools that had been used across other cultural heritage organizations like libraries and archives for a number of years in using what's called named entity recognition. So this was kind of in that vein. The results from that were a little bit mixed. Perhaps this is sometimes they're working with students, you can get mixed results depending on their level of engagement in the subject, but it proved that it was possible that there were AI tools out there. And thankfully, one of the supervisors of the students, Bart Bessons, who was also associated with the Catholic University of Leuven, had a PhD student, Manon Rousens, who was really interested in this, and particularly in seeing how large language models could operate and do this work instead, rather than kind of using these named entity recognition tools, which sometimes can be like complicated, or you need kind of a lot of coding practice to use. Whereas anybody who's used a large language model like ChatGPT, you just have to ask it questions. It's not quite so complicated as that. So she did a couple of experiments with us using some of our collections data and fed kind of 2 different prompts to the large language model to see what it would come back with from descriptions. And it was successful. It came back, it could find keywords. It was varying results, which we are hoping to publish in the next couple of months. So please come back for the link, hopefully to our full article on it. But it proved that it was possible. You could just give something to a large language model and you could ask it to find the keywords within that piece of text, and it could do that. Can't say it was perhaps without its struggles. Like Karen said, one of the things that we've particularly been looking at and been interested in, like a lot of people in AI, is does this technology have bias? I think most people would say yes. And that was immediately proved. So looking at the language, we've been particularly trying to remove things like battlefield trophy from our descriptions and better contextualize it, remove that idea that this taken in battle is like a positive thing. And you can see this description on the left, which a curator has clearly done that work to clean that up and try to better contextualize it rather than using that terminology. And what's the first thing that the large language model has come back with? But battlefield trophy. Have to say it's not necessarily bias was shown on every result, or it happened quite frequently, but it did occur. We did see examples of it, or things like it would make anything to do with the 1700s and it would come back saying it had to do with the American War of Independence. Well, a lot of other stuff happened in that period besides just that, or equally, if it had something to do with Second World War, sometimes it would say, well, that must have to do with Churchill or D-Day, which again, lots of other things happened during that conflict as well. So it didn't happen all the time, but it's definitely something to be aware of when using these technologies, particularly generative AI, like large language models. They do have bias. You have to think about where it's trained and where it's learned its information and at what time period that model is from too, because that will reflect what results it comes back with if it hasn't learned that new information yet. But we wouldn't necessarily say that it happened all the time and it would stop us using it. Like Karen said, at a similar time, we were approached by Axial. This wasn't particularly generative AI. This was, again, going back to more named entity recognition and to do a project with them, as well as a number of other European institutions at the same time, which was really valuable because it wasn't just working on our data set, but it was trying to develop tools that could work across data sets, and particularly something that they could apply back into their collections management system. So it's great doing all this work outside of collections management systems, but like one another colleague has said, you end up with then another data source that sat outside your CMS, whereas wouldn't it be great to be able to have it right embedded in your CMS right away and that information immediately kind of put back in. So it was a really useful project. We did got quite a lot of results out of it. So we ended up with 1,300 new keywords or subjects and close to 1,400 new named people. And those were then applied across 3,000, almost 3,500 object records. And you can see the example here on the screen. This one is a diary which we didn't know had any relation. There wasn't the keyword Battle of Trafalgar on this record before we did the project. You can imagine being the National Museum of the Royal Navy, the Battle of Trafalgar is quite important to us. So the fact that this object now has that listed on there is really exciting. It did make us think a lot, though, about how we ingest this data back into our CMS. How do we flag to people that this wasn't human generated, that it was AI generated? So we have built in some controls in our system to show where AI generated information has come from and when it's not human generated, because the AI systems aren't always perfect. There's definitely errors in the data, but we have to think as well that we make errors too. So one of the big parts of this project and the previous one is that work for curators moved from necessarily generating the keywords to validating and determining whether what the AI models were saying was correct or incorrect. So a lot of time with spreadsheets and them saying yes, no, which kind of adjusted how they worked. And they were really excited about at first, but perhaps waned a little bit as the project went. But we noticed even from that, some of the results that we immediately put back in, even though technically it said it was validated, was incorrect. So it was balancing that risk of using some of these AI tools and the fact that they perform well, but they make mistakes. Well, where is that limit in terms of the mistakes they make that we can kind of say, well, we make mistakes as humans. Can we expect it to perform at 100% all the time? Is that going to be reasonable with some of these? So that was a really interesting debate that we took with these technologies, and that thought of, well, then if we're going to do that and accept it's going to make mistakes sometimes, that how do we then guard to say that, you know, a human didn't generate this like AI technologies did, and therefore allow people to engage with that information or not?
Okay, so one of the other projects that we looked at was photographic descriptions, and the brief for this was to determine the use case for large language models to create descriptions of currently undescribed digitized photographic collections, and if there was a preferred large language model for the task. We knew that others in the sector had tried this out already, and we wanted to see what results we would get for our specific naval collections. Many of our photograph albums only have collection level records for the album rather than for the individual photographs within it. And we wanted a student to explore whether a large language module could help generate these descriptions, as well as whether they would be reliable and historically accurate. We wanted the resulting outputs to be generated in a format that could be easily ingested back into our CMS. The student working on the project, Zizu, selected a set of images to work with from our collections and used a variety of prompts in ChatGPT, Llama, and Wengxin. The initial prompt asked it to generate a description of the photograph, but he then went on to refine it further, giving the context that you are a museum of member of staff, and asking for an output to generate a proper description according to the given examples, which he fed into the large language model. As you can see, this photograph already had a good description with an accurate name, date, and place recorded. A black and white full portrait view of leading wren Ivy Rosina Ryan sitting in a garden, dated October 1942. But the model elaborated or made up information about the photograph, including seeking to attribute subjective words to the image itself, about her pose and how she was feeling and her expression. Some of the models have also failed to read the caption provided on the photograph or interpret the content, such as this image of HOH Prince of Wales Band, which has been described as US sailors with their Harley-Davidson motorcycles, when obviously it is a band on the ship. Zizu was interested in the potential of the large language models to add stories about people or the event in the photograph and to provide more general historical context. Although the results were interesting to us, this more general prompt is risky for us in a museum context, as we require the data to be historically accurate, especially given the limitations of the more specific prompts. However, we think there is potential for refinement, and we'll look to run this project again next year. So another project that we looked at was transcription work, which can be a very labour-intensive process. And we saw the potential for using AI to generate transcriptions from our collection of handwritten diaries. Unlike some museums who have already been able to train a transcription model using large amounts of correspondence or diaries, all written by one individual, we wanted to see what results we could get from a variety of smaller handwritten diaries. The brief for this project was to review existing AI tools for handwritten transcriptions, and determine if there was a preferred tool for the task. The student that worked on the project, Xiang, researched different models and methods, including possible prompts, and looked at whether the tools were viable and reliable. Xiang was provided with a sample of handwritten diaries from our collection. She created a comprehensive pipeline, which included several key steps, including image pre-processing, segmentation, character recognition, and model comparison. She decided that in order for the text recognition models to accurately read the handwriting, that each page needed to be broken down into single-line text images. She experimented using a combination of handwritten text recognition models and large language models for post-processing. Prompts were used to correct potential transcription and formatting errors in the text, whilst retaining the original line breaks. Xiang has compared transcription results across various different models and platforms, including Gemini, AWS, Google Cloud Vision, TR, OCR, and Transcribus. To analyze the results, she has created code to calculate the character error rate between the reference text and the recognized text. She has also used precision and recall metrics to evaluate performance at word level and recorded the execution time per page. As expected, the larger paid subscription platforms provided greater accuracy and quicker processing times, but the free models have also produced very reasonable outputs. The results are very promising for us, and we are hoping to implement the learning into a future diary transcription project.
So thank you very much for listening to our experiments. We're really excited by these different trials that we've done, and we think that they have a lot of potential. Like other people have recognized, AI, and particularly generative AI, where it's generating kind of new data and information, does have its limitations, whether that be a bias in some way. It loves to hallucinate or make things up, as we've seen today. The Harley-Davidson motorcycle always cracks me up, that one. But we do think there is potential, that there's definitely something there. There's a way to kind of help break some of these tasks, which can be really repetitive and difficult for curators or time consuming, and really assist with that. But it's just where and how they're applied, and also the level of risk that people are willing to accept into the data that perhaps is ingested back into their CMS. So we do really see a potential, and we're really excited to find kind of future projects and how we take these kind of beta experiments into wider projects, particularly the handwritten transcription, and how we could perhaps get funding to kind of build that into a bigger project for us. So we're really excited to continue doing further experiments, and also to now build these into more day-to-day work of our curators as we move forward.